Hi, this is a video showing you how to do calculations of delta H, the heat of a reaction, by using the delta H, or heat of formation of the different substances in the reaction. So you'll want to have your thermodynamic data table data packet out, and then also the worksheet that goes with this, because I'm going to do number one with you. So number one, this is the reaction. So H2S plus oxygen is going to make water and sulfur dioxide. So what I did is I'm using page 1 of your thermodynamic packet, and I found the delta H of formation for each of the substances. So the H2S is here. Water is a gas, so it's really important that you notice the state of matter and pick the right one also. And then sulfur dioxide down here is negative 296.8 kilojoules per mole. I didn't look up the oxygen because you will not find it on page 1 of your packet. And if you remember, the reason why is because the heat of formation, the enthalpy of formation of a pure element or diatomic molecule like this is 0. But if you were to forget, you could go to your packet, the very last page. Notice the columns here. These are also heat of formation. So, and the values, some of the same are on the front and the back, and then there might be additional back here. We'll talk about these other two columns later too. But anyways, if you look at the heat of formation and you find the oxygen gas, you'll find that it's 0. So if you happen to forget, you can always look it up. So now that I know those values, I can use this formula. Remember, this is where I'm going to calculate the enthalpy change for the whole reaction. I'm going to sum up the enthalpy of formation of the products, and then I'm going to subtract the enthalpy of formation of the reactants. So when I do that, I do have to use the coefficients, because that's how many moles. So I'm going to interpret the coefficients as moles. So we're going to do the products first over here. So I would take my 2 moles of water, and I'm going to put a big old bracket here. I'm going to multiply that by the heat of formation of the water. And so this will be the water value. Then I'm going to add the sulfur dioxide, so 2 moles of SO2. And again, when you do it yourself, you wouldn't have to put all this detail, but I just wanted to give you one really thorough example. The value for the heat of formation of sulfur dioxide is negative 296.8. So that is the products right here. So you can see that the moles would cancel. So you're really going to end up with kilojoule. In fact, when you start to calculate, you'll get 1077.2 kilojoules. So now I'm going to subtract the sum of the heat of formation of the reactants. So 2 moles of H2S, and I'm going to multiply by the heat of formation of the H2S. And then I'm going to add the 3 moles of oxygen, and the value is 0 for the heat of formation. Whoops, can't talk and write at the same time, just like in class. So this, you don't have to include that term if you don't want to. In fact, when I do these problems, I always go like this, and I just say that one is 0. But it's just to explain it a little better. And if you want to include it, you sure can. So when I do that, remember, this is the sum of my reactants. And that ends up being negative 41 kilojoules. So then you do have to keep track of the sign, so it's the sum of the products minus the sum of the reactants. So it's a negative 1077.2 minus a negative, so that becomes positive. So you should end up with negative 1036.2. And that should tell you that that's exothermic. And then if you were, you're not asked to, but it's good review if you're interested. If you're not interested, you can just be done with the video. But if I were going to draw the enthalpy diagram, remember this is reaction progress. This is a exothermic reaction, so my reactants, the water and the sulfur dioxide would go here. And then my products, which are H2S and oxygen, would go here. So I have a drop in enthalpy. Enthalpy is negative. And if I were going to put this value, it's exothermic. So what I would do if I was going to add it to the reaction is I'm actually going to put it over to the right, because along with the water and the sulfur dioxide, I'm making that energy. It's exothermic, so it's going from the system into the surroundings. So when I bring it up into the reaction, it's actually going to be positive, because I'm saying that I'm going to make water, I'm going to make sulfur dioxide, and I'm going to make 1036 kilojoules. So it's negative when you pull it all out by itself, but when it's in the reaction, it's positive. So I hope that helps.